Use the computer or calculator to find the surface area of revolution about the y-axis of that over the interval 0 to 2. Okay. So here's what we're talking about. I typed it into the calcplot 3D just so we could see it. So this is the function x equals 81 minus y squared, square root of 81 minus y. I put it in right there. That's the right edge. The left edge is 0. You can see the graph. It's going from here, little part of a curve back to there. And then I rotated it around the y-axis. We get that disc kind of shape that we want the surface area of that whole shape. That's what we're looking for, the surface area, the, just this outer surface area right here, is what we're actually getting when we do this formula. We're not getting the top of the disk or the bottom. We're just getting, this side surface area that is created by this little piece rotated. Okay, anyway, there's a picture. Let's dive into the formula. So we're going about the y-axis, and we have a function in terms of y. So let's go find that. So this is surface area. Whoop, surface area, not arc length. So surface area. So here's a surface area, and we're going about the y-axis, and we're going to use this ds to put in right there. Why? Because that's got the dy, that's got all the stuff in terms of y. See how I nailed down which one in particular we need? So again, it's surface area, it's y-axis, and it's functions in y. So y-axis, and then this one, not that one, because that's dx, this is dy. Okay, so there's the formula we need. Let's bring it on back. It's going to equal the integral from a to b of 2 pi, what was it? X, 2 pi x. We're going to have to replace that in a minute. ds, and the ds is the square root, right? The ds is this ds. 1 plus g prime of y, 1 plus g prime of y squared, dy. 1 plus g prime of y squared dy. G prime y squared dy. Okay. So what is g of y? Well, this is g of y. So g of y, I'll change my color here. G of y, that just means a function of y. So this 81 minus y squared to the half, the root right here, that is a function of y, right? That has y in it. That they called it x here. We're calling it g of y. You could call it Tom of y, George of y. It's just a function of y. That's my g of y. That's what they mean in the formula there. And then we need the derivative of that. So the derivative of that, bring the half down. 81 minus y squared to the minus half times derivative of the inside, because chain rule, derivative of the inside minus 2y, right? Derivative of the inside. So let's clean it up a little bit. This minus 2y and this half of 1's, half of 2 is negative, half of negative 2 is negative 1y, 81 minus y squared to the negative a half. There we go. There's g prime of y. So that's what we're going to put in right there. And what do you put in for this x? Well, x is this. So we put x is equal to 81 squared of 81 minus y squared. So what do we get? And what's the a to b? Well, the a to b is on the y-axis, and they tell us right here y goes from 0 to 2. This is 0 to 2. So from 0 to 2 of 2 pi x, x is going to be this right here. So I'll go 81 minus y squared to the half, the root, And then the other part is, so it's this whole thing to the half. Again, this root here is a half power. And it's going to be 1 plus. And then we're going to have g prime of y squared. So all of this squared. So well, we don't need that negative because it's going to be squared, so who cares? In fact, let me make a bracket just so it's easier to see it. Here we go. Y, you can put in negative y if you want to. I mean, there's nothing wrong with it. It's just not going to do anything. To the minus a half. But that's squared, huh? Right? So it's a lot of powers here. You got to remember if there's a g prime of y, which this is all g prime of y, this is right here, without the minus because that doesn't matter. It's being squared. Um, right? To the minus half. That is, that part's the minus half. And then that whole g prime y is squared. And then that's all in a square root, half power. And then we get this in the front. What a mess, huh? Type that all into the Desmos graphing calculator. So I did that right here. See, I typed it all in carefully, painfully. You can't even quite see it all because it goes off the screen a little bit. But I did. I typed it all in um, and got that answer. And that answer was the correct answer, as you can see. So there we go. Oh, I forgot the dy, huh? dy. Don't forget that. So there we go. That's the surface area. You know, the outside surface, this surface all the way around that shape. That's that surface area that that curve makes when it's revolved around the y-axis. There we go.